All right, in this video, I'm going to go over section 7.2, estimating a population mean when sigma is unknown. So chapter 7, we're studying how to estimate population parameters. So in this section, the goal is to study the method for uh, using a sample mean X bar to make a inference about the value of the corresponding population mean mu. So simply saying that we wanna we're gonna approximate the population mean using sample mean X bar. Because the sample mean X bar is the best estimate, it's called the point estimator of the population mean mu. Okay, so similarly, what we did, the 7.1 to estimate the population proportions. So we're gonna find out the confidence interval based on the confidence level, okay, by finding critical value, and then also we can figure out the marginal errors. So the here point estimate, we can sample mean X bar is the best point estimate. Okay, so what's the point estimate? The point estimate is a single real number, which is called a single value estimate. Okay, of the population parameters. But in this section, population mean view. Okay, so confidence interval is what confidence interval is the using the sample data to construct and interpret confidence interval estimate of the true value of population mean mu. So confidence intervals consist of the, as you can see, that x bar minus e and then x bar plus e. So e is margin of error. D is t times s over square root n. So here we assume that the population is normally distributed. What that means, the population is normally distributed means that the the population um this sorry the probability distribution of the population is has the bell shape. Okay, so and then the bell shape. Okay, and then the we gonna select the sample randomly, and then the number of the sample size must be greater than, depending on textbook, but 30 in this textbook. Okay, some textbooks say that 25. Okay, so s over square root of n is the actually the what standard deviation of the mean of the sample mean. Okay, so it's the um now the thing is this, t is the t value is called in the standard t distributions. So as you can see that the t distributions has a similar to look at the shape of the t distributions. So t distribution is similar to the normal distribution, right? Actual standard normal distributions. So now, then let's see. Now, so to find out the t value, okay. So to find the critical t value, oh, wait a second. Now the main difference between the 7.1 and 7.2, I mean, estimated population proportion and estimated population mean when sigma is known. So then in the population, we to estimate a population proportion, we use the what z score, right? So just z score, but here we use t score. It's called t is t distribution from the t distributions. Okay, so here's the PowerPoint lecture slide. So margin of error, e, can be calculated by like this, but yeah, eventually we're gonna use a calculator to figure out confidence interval. But you need to understand the concept and the formula of the terminologies. Okay, so t sub alpha over 2, like alpha over the z alpha over 2, t sub alpha over 2 is just the the number on the borderline separating the significant low and significant high the values. So population mean. Okay. So now here df is degree of freedom defined by n minus 1. Okay. S is the samples, the standard deviations. Okay. And then n is the sample size. Okay. So as you can see, the confidence interval is associated with the confidence level such as 0.95 or 95%. And alpha is the complement of the confidence interval. Okay. This is also called the significance level, but then so for confidence in the case of the alpha, the confidence level is 95%. Alpha going to be 0.05. The alpha over 2 going to be 0.025. Then we can use the now critical value t sub alpha over 2. I mean, definitely we're gonna use calculator to figure out the t sub alpha over 2, but you need to figure out alpha first. Okay, and then we're using the calculator. I'll show you later. We're gonna find out t sub alpha over 2. So t sub alpha 2 is a critical value. Is the yeah, so separating, I told you, area of alpha between the right tail of the CNT distributions. I told you we see that the graph of t distribution, right? And then so give me a second. So here you can see that the the graph is the standard normal distributions, and the other two, the red and the orange color graphs are t distributions. The red one, red curve is a t distribution with n equals 12, sample size 12, and then the orange graph is the t distribution with n equals 3. As you can see, the n is increased, which means the sample size increase. T distribution approach the standard normal distributions. Okay, so now and then alpha over 2, mm, let's say not here. So for example, given alpha critical level is 95%, alpha is 0.05, so alpha over 2 is 0.025, right? So that means, for example, right here, let's say this is minus t alpha over 2. So actually alpha over 2 is the area, and here this is area under the graph of the t distribution from negative infinity to negative t of alpha over 2 is alpha over 2. And then there is, so right tail, so this is t alpha over 2. Okay, so that area is what? Alpha over 2. Okay, so t alpha over 2, this is called the what? Critical value. As you can see, that separating the area of alpha over 2, okay, the right tail of the t distributions. So that area represent what? The probability that we get significantly high estimate, okay, for the population mean mu. Okay, so this is what that area represent probability that we get significantly low estimate, point estimate of population mean mu. Okay, so we have to drop those area. Okay, so now the back to the second, back to the lecture slide. So here, and then degree of freedom, I told you df n minus 1. So that's also one of the difference between uh, the uh, the estimating population proportion and here this section of estimated population mean. So in the when you we didn't when you find out the what critical value, we didn't use the degree of freedom, right? In a when you in a 7.1 population proportion, right? But here we're going to use a df instead of n. We can use a df degree of freedom. Okay, it's defined by n minus 1, the number of the degree of freedom used when finding critical value. Okay, so now next one, the confidence interval for estimating population mean with a sigma not known round of rule. Yeah, so we see round of rule. So when using original set of the data value, round the confidence interval limit to one more decimal place than is used for original set of data. Yeah, let me apply this one to the examples. Okay, And then when using summary statistic n, x, and s, round the confidence interval limit to the same number of decimal places used for sample mean. Yes, we'll apply that. So here's now let's study about the student distribution. Okay, clearly. Okay, so to figure out this one, okay, clearly. So student the t distributions. If a population has a normal distribution, then distribution of t is this. Also, yeah, you don't have to memorize it, okay? So, but just please understand, just look at this one. So x bar minus mu over um, the this is the what the by the center limit theorems. This is the standard deviation of the mean of sample mean. Okay, so since why we use this, because when you z-score, we use x bar minus mu over sigma, right? Because here, but in this section, we assume that we don't know sigma population standard deviations, so we use the approximation of the what the sigma, which is s over square root n. Okay, so that is a student t distribution for all sample of size n, and a student t distribution is commonly referred to as a t distribution. Yeah. So it's really similar to that formula is really similar to the formula of z-score, right? And then give me a second, and then the n is increased, then s over square root n approach sigma. That's why the graph of t distribution approach standard normal distribution as n is increased. Okay. So now and then yeah, let's see. Degree of freedom finding a critical value t sub alpha of 2 D requires a value for the degree of freedom df df. Yep. In general, the number of degree of freedom for a collection of sample data is the number of sample value that can vary after certain restrictions have been imposed on all data values. For the method of this section, the number of degree of freedom is the sample size minus 1. So the mm, if you take the yeah, so I mean the while we have, you may wonder that, okay, so while we have to subtract 1 from the sample size, because the mm, simply saying that when you select the data, when you select the data to construct the sample space, okay, and then the one of them is really close to the sample mean, so we subtract the that data. I know it's really hard to understand. It maybe it's probably you find it challenging to understand degree of freedom. But um, if you take you'll understand when you take the advanced statistic course. So, but the explain this one is beyond of this subject. So I'm not gonna express. I'm not gonna explain why you subtract. We have to subtract 1 from n. But so just let's just set the yeah degree of freedom, okay, is n minus 1. And then now then next one I told you, so this we haven't seen this one, right? We haven't seen the graph here. And then let's back to the lecture, my lecture, the handout. All right, let me find the confidence interval um, estimate for the mean speed, okay? So since the data is given, right, 62, 61, and then when you look at the example was in my lecture handout. Let's see. The example gives us the sample data, right? So in the, we assume that the sample data is collected by a simple random method. I mean, randomly. Okay. So then the problem doesn't give us the what sample. I mean, sorry, population standard deviation sigma. So we don't know sigma. Okay. And the problem asks us to figure out constant interval of the population mean. so mean speed, right? So first you have to enter the sample data in calculator. So go to the press tab, and then you see the edit, right? So edit, go to edit, and then I already entered the data in the column L16. Okay, so column L16. So now then we go to the press stack again. Okay, there you see the test. There are 3 tabs: say edit, calculate, and test. We go to the test. Okay, so we're gonna use t distribution, right? So when you see that t number, see that for my calculator number 8, t number, that's the intrinsic function to estimate confidence interval using t distribution. Okay, so just enter. Okay, so now then there are 2-way input and stack. Okay, some problems give us the uh, the sample mean, and then sample standard deviations, and then sample size instead of the giving the a sample data. Okay, so for this example, since the problem gives us a sample data, so we use the data. Okay, so we choose the data, not statistic. Okay, so enter, choose the data, and then what you have to enter the column name, what you enter the sample data. So for me, I enter the data in L16, so I just entered L16. Someone asking me that wonder that where is a letter L, how to put a letter L. You see the L right there, here. Okay, so press ARPA. We don't have the alpha, so for example, delay here. See that if you look at the course A, it's A, right? Is it the letter A is a blink, right? It means that already that key is what that is already on. Okay, so now we just press this one L, and then to enter the number, we have to off that function, and then number 16. The frequency leave it 1 as frequency, and the confidence level 0.5 at the calculate. Will take time. So now you see that the interval, that's confidence interval. Okay, and then x bar is just 60.66. Okay, so now in the SX, that's the sample standard deviation, 4.05, and then n is 12, which means the sample size 12. So now then to figure out the margin of error, we subtract what? I mean 58.078. That's the x bar minus e, and then the right number in the interval, that's going to be x bar plus e. Okay, so adding two number divided by 2, that's going to be margin of error. Okay, so this is how to find out here. And then when you look at the my lecture handout, you see normal the quantile plot is shown in the graph in the handout. Then how can you plot the normal quantile plot? I'll show you. So we go to the stack. Okay, and then you enter the data in a column, but we already did it, right? So we go to the stack plot. Okay, press second, and then press y equals, so here, and then just on plot 1. Okay, and then you see that in a type, the last one, that's the normal quantile plot. Okay, so now and then the data list L16, the data axis set X. Okay, choose X. Okay, and then press zoom and number 9. So you get this. What does that mean? Normal quantile plot. Through the normal quantile plot, we can figure out the data is normal distributed or not. Okay, so see the square marks represent the sample data. I mean, each mark represent the a point whose x coordinate represent the sample data value, single sample data value, and then y coordinate represent z score. Okay, so for each dot. Okay, for example, um, I think the first mark represent that point. Its x coordinates must be 54, because I think 54 is the minimum data value. So 54, and then its y coordinate must be g score. Think of negative um, negative to something approximate. Okay, so now you see that, right? So what can you figure out from that one? If the distribution of these point are just close to the linear straight line whose equation is y equals x, then the sample data is approximately normally distributed. Okay, so using the by plot, there are several ways to figure out the sample data is normally distributed or not. Okay, just through the histogram or frequency polygons or other graph, but by normal quantile plot is the one of the way to figure out whether or not the sample data is normally distributed. So see that here, I can see that that one is it's kind of straight line, right? Y equals close to straight line, right? So now we can see that, oh, that's the then what the sample data must be approximately normally distributed. Okay. All right. So now let's see next example. So in next example, problem give us sample the what sample statistics. Okay, so here sample statistics. Statistic means the characteristic of sample space. Okay, or sample data. So it means that sample mean, sample standard deviation, sample variance, or sample proportions. Okay, these are called the uh, popular sample statistic. Okay, so I told you the parameter is what? Parameter is a popular characteristic of the populations. Okay, so the see 16 subject treated with zopiclone for insomnia had wake times which are normally distributed with a mean of 98.9 minutes. You see that? That's the sample mean, right? 98.9, and the sample size 16. Then what DF freedom must be 15, right? Keep in mind that. And the sample standard deviation is 42.3, okay? And the confidence level is 98%. It means the RPA must be 2%, which is 0.02, okay? So now comes the interval estimate for the mean wake time. So before treatment, the subject had the mean wake time of 102.8 minutes. So those Jopicolin appear to be effective. Okay, so now let's figure out that whether or not that one is the, you know, is in the comes interval or not. Okay, so now see. First one, we need to figure out what critical value, right? T sub r power 2, right? So confidence level is, I told you 98%. Let me write down the sample size first. N is a 16, right? Should be lowercase n. Okay. So it means the DF must be n minus 1, which is 15, right? And then the X bar, okay? So give me a second. Oops, that's too big. X bar is equal to, yeah, give me a second. How does it work? Right, X bar is just 98.9. Okay. So and then S is sample standard deviation is 42.3. Okay. So now confidence level is 98%. So alpha, let me just say alpha, okay? Or give me a second. Yeah, alpha is equal to 2%, which is 0.02. So then alpha over 2 is what? 0.01. Okay. So let's find the critical value t. Okay. T sub alpha over 2. Let me but skip writing the subscript alpha over 2. Okay. So critical value t is going to be lowercase t, right? So let's find out this critical value. Okay. Using calculator. Okay. So okay, in the calculator we go to the distribution. Okay. So the purpose, I mean, when you find out the confidence interval, you go to the list stack. Okay, you go to stack and then go to the test. Okay, and then to figure out critical value. Okay, so z sub alpha 2 or t sub alpha 2, you will go to the distribution. Okay, so press second and then variable. Then there is a inverse t. Do you see the inverse norm? That's the intrinsic function to figure out the z sub alpha 2. But we're gonna find out. We have to find the t sub alpha 2. So inverse t. Then they're gonna ask the area, 0.01, right? So you enter the alpha over 2, which is 0.01. And then df is the degree of freedom, which is n minus 1. Okay, so which is 15. The paste. So we got negative 0.2 negative 2.602. Okay, so that's the what key in mind is in the inverse norm inverse t in that calculator return the z score or t value whose area from negative infinity to okay area on the left tail area of the left tail, okay, not right tail. Okay, so what that means, in the let's say this is the t value right here, then the graph is maybe like this. Okay, so here's the mean. Okay, so now let's X bar. Okay, so X bar here. Then this is alpha over 2. In this case, 0.01, right? Okay, so calculator just recognize the area of what you entered in calculator is this here, area of that left tail, not right tail. So we got the minus 2.602, right? Then so this is gonna be what is a negative t sub alpha over 2. But we need to find out what t positive, t alpha over 2, right? So that must be what this is equal to 2.602 because normal distribution, standard normal distribution, and t distribution must be symmetric about the vertical line in the center passing through the mean. Okay, simple mean. So this t sub alpha over 2 must be 2.602. Okay. Now then let's find out then the what confidence interval. Once you figure out the critical value, now we are ready to figure out, I mean estimate confidence interval. Okay, so we go to the stack. Okay, so now the test, and then we use the t interval, right? T interval. So instead of data, we have to choose stack. Okay, then x bar must be what the problem says, that x bar sample mean is 98.9, right? 98.9. Okay, and then sample standard deviation is 42.3. Okay, and the n is what 16. The c level is what, second. So now 0.98, right? So point second 0.98. Okay, yeah, I was just confused that in this case we didn't have to figure out the t critical value. Okay, but it was good for practicing, right? So now we got the confidence interval right here. Okay, you see that. So now the back to the problems. So it says that there's one more question. So before treatment, the subject had mean wake time of 102.8 minutes. Does Jupyter clone appear to be effective? I don't think so, because a 102.8 minutes, that is in that interval, right? Let's see. Okay. What I mean is this. Here, the by the way, let me copy the context interval CI. Okay. So that's the 71.379, comma 126.42. That's context interval. What does that mean? The 71.379 and comma 126.42. That's the what the we well we confident we are confident that the population mean wake time after treated without Jupyter. Okay, so the what is included in that interval with a 98% confidence interval. Okay, so for example, you just select the samples data. You just select the 100 sample data. Okay, some place 100 sample spaces. Okay, and then you just calculate the confidence interval. Then 98 confidence intervals contain the actual, true population mean. Okay, and the other two confidence intervals do not contain the actual confidence, actual the population mean. Okay, that's the meaning of this confidence interval. Okay, so by the way, so that's the key mind is this is confidence interval. This is means that well we are confident that the population mean wake time after treated with Jupyter is there. Okay, so but the problem says that here before treatment the subject had a mean wake time of 102.8. 102.88, that's the what the sample mean before treatment. Okay, but 102.8 is in that universe. Okay, so probably, okay, based on that statistic, the 102.8, since the 102.8 is in that universe, so maybe 102.8 could be just or close to the population mean wake time after treatment. Okay, so what that means, the job clean is not effective. Okay, right? So because 102.8 is in the complex interval. Okay, so does Jupyter appear to be defective? No. Okay, so what if just the number is not 102.8, some at the outside of that interval, for example 130 minutes, then yeah, so we can say that based on that statistic sample data, sorry, based on the sample data, we can say that Jupyter appear to be effective. Okay, but anyway, so the answer is what? No. Okay, because 102.8 is in the complex interval. Okay. All right. Now next one is oh, by the way, so please the see the examples in the lecture slide, PowerPoint lecture slide. Okay. All right. So next one, we're gonna see this one, finding the sample size required to estimate the population mean. So now then here we use the second right here. Second. Now, yeah, so definitely we're gonna use the formula of the E. Okay. Yeah, so here's a PowerPoint lecture slide. So we're gonna use this one. And interesting is this, we're gonna use Z, okay, Z score, not T score anymore, okay? So that they definitely problems give you the population standard deviations, okay? So sigma right there, okay? So now then the margin of errors must be given the problems, okay? So now the z sub r power 2 is the critical value of the standard normal distribution, okay? What if alpha is not given a problem? Then we approximate the, the standard deviation, population standard deviation sigma by range divided by 4. You can then round up to the next whole number. But um, I mean, once we approximate sigma by range divided by 4, okay, and then we calculate, then we're gonna get certain. If we get the certain decimal expression, then we have to round up to the next whole number because n must be integer. Okay, so now see, this is not what I told you. Okay, so let's see. Um, back to the lecture handout to see examples. All right, see how many students must be surveyed to estimate the mean IQ of college students to within 3 IQ points. Within 3 IQ points, so 3 must be margin of error, right? E. The 95% confidence, so confidence level is 95%. So using that, yeah, confidence level, we can figure out the Z sub alpha over 2, okay? Because alpha is 5%, which is 0.05, then alpha over 2 must be 0.025, right? And the IQ test typically have a standard deviation of 15. So that's the what? Sigma. Okay. So population, standard deviations. All right. So now then here n is what? N is equal to, let's see. So should be lowercase n, right? N is equal to bracket and then z. To find out z score, we use the inverse norm, right? So what I mean, so we're gonna go to the distribution. Okay, so press second and the press variables. Then you see the inverse norm, right? Okay, area must be what? R power 2, half of 5%, which is 0.025. Then mu must be 0 and the sigma must be 1. Okay, so paste. Okay, so we got the negative 1.96, right, approximately. So R power Z R power 2 must be 1.96. Okay, so see, that's going to be 1.96, right? 1.96 times, and then sigma is what? 15, right? Okay, the divided by E is 3, right? And that's square. Okay, so I got the 96.04, 96.04. Okay, and then we round up, okay, to a whole number. So there's going to be 97, right? So this actually um, the answer is 97. Okay, so we need a 97 student. We need to survey 97 students to estimate the mean IQ um, within 3 IQ points within 95% confidence. Okay, so the next example, how many students they must be surveyed to estimate the mean annual college tuition paid in the US with 99% confidence and $100 margin of errors. Assume that college tuition range from $0 to $45,000. So that's a range, right? Then the sigma, we approximate sigma population standard deviation going to be of you know the $45,000 divided by 4. Okay, so now then the, I mean, you may wonder that why we divide by 4, okay? Because we consider that the minimum, see that? Give me a second. Yeah, so range is maximum minus minimum, right? Minimum. So we consider the maximum is just the mu minus 2 alpha, plus 2 alpha, and the minimum is mu minus 2 alpha. Okay, so now then plug in mu plus 2 alpha into maximum, mu minus 2 alpha into minimum. We're gonna get this mu plus 2 alpha minus mu minus 2 alpha, which is the 4 alpha, 4 sigma. So this should be sigma, right? Sorry, sigma, sigma, sigma. Okay, remember that mu plus 2 sigma, that's the borderline to between the significance high and then just the user, right? Mu minus 2 sigma is considered that just the borderline between the significance low and then just user data, right? So then we're gonna get 4 sigma. Okay, we just consider that mu plus 2 sigma is maximum, mu minus 2 sigma is minimum. Okay, so we divide by 4, then we're gonna get, well, approximately the sigma, right? Okay, I mean that's, yeah. So that's why. So now the back to the handout. So now here, the composite leverage 98%. So the ARPA must be 1%, which is 0.01, right? The ARPA over 2 is 0.005. Okay, and then the margin of error E is 100, right? Okay, and then the sigma gonna be 45,000 divided by 4. Okay, so the n is equal to the G score. Yeah, we gotta find the G score, right? So just then give me a second. So right here, back to calculator. Okay. So now we go to the distribution, the inverse norm. Our area must be what? Alpha over 2, which is 0.005, right? Okay. So mu 0, sigma 1, leave it, and then calculate. So we got the minus 2.56. Okay. So that's the minus z sub alpha over 2. So positive z sub alpha over 2 going to be 2.56. Okay. So back to the slide. So this is going to be 2.56. Okay. Times what? Sigma, which is a 4 over 45,000 divided by 4. That's 11,250. Oops. Okay. Divide by marginal error, which is $100 in the square. Okay. So let me use calculator. So I got 829, 829, and 4. Okay. Okay. So let's say next example. The random sample of the birth weights of 186 babies has a mean of 6.84. So sample size of 186, and then sample mean is 6.84 pounds. Standard sample standard deviation S is 1.53. And these babies were born to mothers who did not use cocaine during their pregnancies. So construct a 95% confidence interval estimate of the mean birth weight for all such babies. So, okay, so now then back to the, okay, let me use calculator to figure out the sample, to estimate the confidence interval, okay? So now we go to the stack, okay? So it's a test right there. So we use the t interval, right? We gotta use t interval, right? Why? Because the problem doesn't give us what? The sigma standard normal population standard normal distribution. we don't know yet. We don't know that, right? So we use t is number. So now we choose a stack, right? Okay, stack, and then x bar is 6.84, and then the sample standard deviation 1.53, and then sample size is 186, and the confidence level is 95%, which is 0.95. Okay, okay. So calculate this. It'll take time. So yeah, we got this confidence number, which is a 6 point see that 6.6187 and 7.0613, and then sample yeah, x bar is a sample mean, and the x is a sample standard deviation, and your sample size. Okay, so now the next example, next question in the same example. So compare the confidence interval from part A to this confidence interval obtained from birth weights of babies born to mother who use cocaine during pregnancy. See, mu is 5.75, and then greater than and less than 6.16. So you can see that that confidence interval, you know, and then that comes these two confidence interval uh, those two confidence interval doesn't do not have overlapping part, right? Okay, so definitely then what the cocaine use, yeah, cocaine appear to affect the birth weight of baby. Okay, so definitely then what the what there is what in that, see that comes in number, then population mean view what is the what same confidence interval 95%. Okay, we confident that what this population mean is is in between 5.75 and 6.16 pounds with 95% confidence level. Okay, but in the A, that comes in our means that what we confident that population mean is between 6.6178 and the 7.0613 with a 95% confidence level. And then since there is over here, in here, there is no way that what based on that simple simple statistic, there's no way that the confidence population mean is beyond, or less than, beyond of that interval, right? So, and then also in here, that comes interval, there's no way that that population mean is beyond of that interval, comes interval. Okay, so now then what, based on that statistic, a sample statistic, then what we confident that what the population mean, um the birth weight. Okay, all right, so born to mothers who use cocaine during pregnancies less than the population mean, okay, of the birth weights, of the babies born to mother who did not use cocaine during their pregnancies. Okay, so that's the reason. Okay, so the answer is yes, the cocaine appear to affect the birth weight of baby. Okay, so now next one example. How many cars must be randomly selected and tested in order to estimate their mean braking distance? So this problem is what is about finding a sample size required, okay, to get what, so 99% confidence level, and then sample mean is within 2 feet. This is margin of error, right? Okay, and the braking distance range from approximately 120 to 150. So we consider that 120 is what, mu minus 2 sigma, 150 is mu plus 2 sigma. Okay, so 150 minus 120 divided by 4. Okay, that's going to be approximation of estimate of the population standard deviation sigma. Okay, so the n going to be, well, so definitely we're going to find out what critical value, right? So z sub alpha over 2 using calculator. Okay. Yeah, you can use calculator, but we already figured out z sub alpha over 2 with the confidence level 99% in previous example, right? So it was 2.56, right? So 2.56 times. Okay. So 2.56 times, and then the sigma, which is range divided by 4. Okay. So that was 30 divided by 4, right? Okay. Now then, what? Divided by marginal error 2. Okay, and then square. Okay. So let me use calculator to figure out decimal expression. So I got 92.16. 16. Okay. And then you should always choose next larger whole number. Okay, it means a round up always. Okay, so which is 93. So the answer is 93. The answer is 93. So we need to select the 93 cars. Okay. So that's the all about the section 7.2. Okay. So I'll skip the other section in chapter 7. Okay, next time I'm gonna cover chapter 8, hypothesis testing. Okay, that's the next topics in inferential statistics. Okay, let me stop here.